All right, guys. So here we're determining proportional relationships. Again, I got to figure out, are all of my fractions the same? From a table of values. Now, again, we must reach two criteria. We need to meet two rules. It must start at the origin, which again, I got to start at 0, 0. 0 must be paired with 0. If it's not, it's not proportional. And then must have the same constant ratio. Again, all that means is all fractions are the same, okay? That's all we're doing. So now, with that said, we've got our constant of proportionality, which is y over x. That's what this says right here, yeah? And again, our origin is just 0, 0. Okay, first things first. Does it start at the origin? Does it start at 0, 0? Or really, you're looking for, is 0 paired with 0? And yeah, it is. So hey, I don't need that. Okay? Now from here, are all the ratios the same? Are all my fractions gonna be the same? All right, well, I mean, we gotta do all of them, so we might as well just start at the front. Y over x. Now take a look, you guys. This column right here, or this row right here, what the heck? I don't know what that was. Is the y values, and this is my x values. So please make sure you put the numbers with the right ones. So the y value for the first one is 30, and the x value is 12. Once you guys do that, let's break these numbers down. So if you guys have your multiplication chart, hey, I got 6 times 5. Is the 6 or the 5 prime? The 5 is, huh? All right, well, let's break the 6 down then. Remember, cross them off when you break them down. And hey, look. 2 and 3, those are also prime. So those are all numbers I want to put right here. Now, I would highly suggest, again, that you guys put these in order from least to greatest or biggest to smallest, whatever you guys want. As long as they're in some order, it'll make it easier for you. All right, well, 12 is 3 times 4. And I know 3 is prime. 4 is not, because 4 gives me a couple of 2s, yeah? Okay, well, there's my factors, 3, 2, and 2. So let's put a 2, and a 3. Now, really what we're doing is that 30 over 12, we're simplifying it. And we're making it as small as possible for the most correct answer for us, right? Because 30 over 12 is correct, it's just not the simplest form. So let's cross off numbers that match. I got a couple 2s. Those are gonna turn into 1s because 2 divided by 2 is 1. And hey, I have a couple of 3s. Okay, well, all that's left on top is a 5, and all that's left on the bottom is a 2. So there's my ratio, my fraction. Okay, well, what that's telling me is that for these other ones, I got 5 over 2 here. I better get 5 over 2 for the rest of them. Because if I don't, then it doesn't work, okay? Now, it said, do we start at the origin over here? Yeah, we already said that. We said on the left side, okay? So cool, hey, I need to check the next one now. I have a 20 and a 10, so let's do the next one. And in the green with the y values, it's a 20, so I'm gonna put a 20 on top and a 10 on the bottom. All right, let's start breaking these things down. So 20, 5 times 4, or 10 times 2. You can use any one you want. According to our list, 5 is prime, so I'm just left with 2s from this. And you'll notice that you'll start to see a lot of numbers that break down and we're doing the same thing. So 2, 2, and 5. And on the bottom, I got a 10, so that's 5 times 2. And hey, those are both prime. So 2 and 5. All right, from here, you guys just start breaking down. So I got a 2 on top. Those 2's right there that crossed out made a 1. The 5's that crossed out made a 1. So we could throw a 1 underneath. Are these two numbers the same? No, they're not. So, no, it is not proportional. And the reason why, proportional. The reason why is because the fractions are not the same. Really, it's straightforward as that, okay? So our goal, and really it's the same thing every time. Do we start at 0, 0? Or is 0 paired with 0? And do all my fractions match? If so, it is proportional. If not, then it's not proportional. I mean, it's pretty straightforward. So next one, first thing we start off with, does it start with 0 paired with 0? Is 0 paired with 0? Yes, it is. So does it start at the origin? Yes, we do. But I don't want to use these numbers because I can't divide by 0. It's not going to help us out. It just tells us where we started. Okay. But uh-oh, we got some funky stuff here with the fractions. The heck? All right. So this first one, the second one. All right. Well, r equals y over x. The y value goes first. Okay. So that's 2/3. Now with fractions, I'm going to write this out a little differently just because I don't want to put them on top of each other. I'm going to write it out this way. Only with fractions though. Okay? And remember, when dividing fractions, we have this little rule that you guys learned back in elementary school. We want to keep, we want to change, and we want to flip. Now, all this means is keep the first fraction the same. So that first fraction, you're not going to mess with. I'm going to keep it. But I do want to change, we want to change this to multiplication. So from division, I want to change it to multiplication. And then the last one, we're going to flip the last fraction. So I'm just going to turn it the other way. Okay? So again, keep, change, flip. If you guys need to push pause to keep writing, go ahead and do that, but I'm going to move on now. So when dividing fractions, I keep, I change, I flip. So keep this fraction, change the sign, and flip this. All right, well, 2 times 3, 6. 3 times 1, because we multiply straight across when it comes to multiplying fractions. So 2 times 3 on top is 6. 3 times 1 on the bottom is 3. Let's break these things down. So I got a 6, I got a 3. 6 is 2 times 3. Hey, those are both prime. Whoops. And then 3, well, 3 is already prime, so I don't need to do anything with that. So on here, I got a 2 and a 3. On the bottom, I got a 3. Can we cross anything off here? So I'm left with a 2, but remember, it makes a 1 underneath if there's nothing there, so 2 over 1. So we have 0 paired with 0, and now my fraction is 2 over 1. So that means every other fraction better be 2 over 1, okay? All right, cool. So with that said, I got to try the next one now, which is 24 and 12. So I'm going to make this. Uh, 24 is with the y. 12 is with the x. Yeah? All right, let's break these things down. 24 is 8 times 3, or 6 times 4. You can get the same thing either way. 3 is prime. And then here I got 4 times 2. 2 is prime. Now remember, I mean, I've seen it quite a bit. 4, you guys think it's prime, but it's not. I can multiply and get a couple 2's out of there. So make sure you break down these numbers as far as you can. So all that's left for us is a 2, a 2, a 2, and a 3. But for 12, whoops, I got 6 and 2. And then 6 is 2 and 3. All right, 6 times 2 is 12. We break down the 6. 2 times 3 is 6. All these numbers are prime, so now I'm done with that. So I got a 2, I got a 2, and I got a 3. All right, well, let's start crossing things off. So I got to cross off that 2. I could cross off the 2 and the 3's. So we're left with just a 2, but underneath, hey, that's good. Now we just need to try this last one. So 10 and 5, a lot easier numbers, huh? And if you look at your list, the 10 is the y, the 5 is the x. So 10 gives me 5 times 2. Love that it's not a lot, less for us to have to write. So 2 times 5. And then if I were to break down the 5 on your list, 5 is prime. Cross off the ones that match. All we're left with is a 2. We put it over a 1. Are all of our fractions the same? Yeah, they are. So yes, it is proportional. And again, the reason why, we started at 0, 0, or 0 was partnered with 0, and all the fractions were the same, okay? So we're just about done, okay? The fractions can get kind of tricky for us sometimes, but to be honest, as long as you guys put the y1 first, keep change flip from there, it's not too difficult, okay? Okay, do we start at the origin? Is 0 paired with 0? No, it is not. Easy. No. Not proportional. We got to follow both rules, you guys. And if it doesn't, you can just stop and say, ha, that's way too easy. Thank you for helping me out. Okay. With that said, I'm gonna do one last one with you guys to keep change flip, and then you guys can finish that one up on your own. So here we go. First things first, is that 0, 0? Yeah, it is. But I don't need to use those, okay? Mixed fractions, though. Remember, there's a little shortcut to help us put it as a regular fraction. So I got 12 times 2, which is 24, plus the one on top, which is 25. And then whatever your denominator is, that's what it stays as, okay? Now, you won't see one of those on the test, but I mean, it's still good to know. It's stuff you guys have seen before. So this is 25 over 2. So I'll do the 2 fraction ones, then after that, you guys can do the 12 and the 10, okay? So my y is 25 over 2. And then my x is 15. But I got to put a 1 under that, okay? So from here, remember, keep, change, flip. So I keep this the same, I change this, and I flip this. 25 on top, 30 on the bottom. 25 times 1 is 25, and then 2 times 15 is 30, yeah? And then break these things down. So I got a 5, I got a 5. 30. I got a 6 and a 5, but I know that 6 is not prime, so I break that down to a 2 and a 3. All right, well, from here, 25, let me move this a little bit. 25 is 5 and 5 on top, and then on the bottom I have a 2, 3, and a 5. So the 5s cancel out, and all I'm left with is a 5 on top, and then 2 times 3 on the bottom is 6. So make sure you guys go through, do the other 2, and see if they all give you the same thing. See you guys.